Okay, so I really like this example, and the reason is it employs a little bit of common counting that we learned previously in kind of going about this, because when they ask for how many whole numbers, you're using both kind of divisibility or division, and you're using counting. And what I mean in specific you're using in counting is casework, the idea of splitting into cases based on some criteria. And in this case, our criteria is going to be the units digit of the number. So first off, we're just going to write out all the possible units digits, right? Because there's only 10 of them. So u equal to, I'm going to call it u equals 0, u equals 1, u equals 2, u equals 3, u equals 4, u equals 5, u equals 6, u equals 7, u equals 8, and u equals 9. Okay, so 0, there's nothing that, so it's the number 64 has a property that it's divisible by its units digit. How many such whole numbers? So anything ending in 0, nothing is divisible by 0. So like there's none here. So the 0 total. What ends in 1? Well, between 10 and 50, so we have 11, 21, 31, and 41. All of them work. So we have 4 here. So the next one is 2. So we have 12, 22, 32, 42. All 4 of them work. So that's 4. So now we'll start to get to the case where things don't work. So we have 13, 23, 33, and 43. None of these work. So it's only this. So that's 1. So here it would be 14, 24, 34, and 44. Neither of these two work, so it's just 2. Okay, so 15, 25, 35, 45. All of these work, so 4 work. So you're just going through the cases and writing down what numbers end in a certain units, have a certain units digit, and then you're checking the condition on them to see whether they are divisible by its units digit. That's basically what you're doing. And you're finding out from each case how many total numbers are there, so then you can sum them all up at the end. Remember, that's the property of casework, or the idea of this of casework as a whole. So now we're just going to continue with that process. None of these work, so it's just this. So 1, 17, 27, 37, 47. None of these work. So that's 0. Then here it's 18, 28, 38, 48. None of these 3 work, is this one. And so that's 1. And then 9 is 19, 29, 39, 49. In fact, none of these work. That's 0. So you sum all the cases up: 0 plus 4 plus 4 plus 1 plus 2 plus 4 plus 1 plus 0 plus 1 plus 0. So when you sum it up, you get, so it's 9 plus 2, which is 11, 11 plus 4, 15, 15 plus 1, 16, and 17. So there should be 17 numbers between 10 and 50 that have this property. So it's a pretty nice problem because it employs, like I said, casework, and then it also just requires you to quickly go through each case and figure out what's divisible by what. And for that reason, I would recommend you guys to kind of have an idea what, for out of 2-digit numbers, what numbers are divisible by what. So for example, off the top of my head, I can say that 33 is divisible by 11 and 3 because it's 11 times 3, and things like that. So that would really come into handy. So I would just practice your ability to break 2-digit numbers into prime factorizations mentally. Okay. So next example, how many positive integers less than 50 have an odd number of positive integer divisors? So through this, we can discover a property, which I will talk about when we try to solve the problem together.